Hello everyone, and welcome back to ECS30. In this video, we're going to walk you through your very first program, Hello World, and start explaining a little bit of what's going on inside of it. So what I have over here inside of Sea Lion is a very simple program, and you'll get this program if you start up any project in C. It'll have everything here except these comments. So the first thing that you're going to notice are these comments right here. They start with a /* and end with a */. These guys here are just nice little extra stars that the IDE added in for us to make it look pretty. But everything inside this /* up until this */ is called a comment, and it's actually ignored by the compiler. But it's still really important if you want to write high quality code that you do put good comments inside of it. These comments are here for other humans to read if they have to read your code, or for your future self if you ever come back to a project. What you should do with your comments is explain what and why is going on. The why is a lot more important because the what should hopefully be apparent inside your code. But sometimes you're doing something that's really complicated, and those comments will be there to help you out. Also, you can see that we have another comment down here. So if you want to do multiple lines, it's /*// everything in between them. And if you only want to do a one-line comment for that single line, it's //. And these comments can appear on the same line as other C code. So if I wanted to, I could move this comment from here down to this line, and everything after this // is going to be ignored. So if we work our way down the file, we're going to see that on line 6 we have this #include stdio.h. So C doesn't have a lot of features built in natively, but there are many libraries that you could include, and when you include them, you can use the code that's inside them. What we're including right here is stdio.h, and this stands for standard input and output. This is what's going to allow our code to make access of the printf function on line 10 so that we can display things to the screen. And it also contains other functions that are going to allow us to get input in future programs. So working our way down, here we see int main. All of your programs begin at main. This is our starting point for every single program. So we're going to start here, and then we're going to work our way down line by line by line, executing each line as we encounter it. There can only be one main, so it's like Highlander, because if there were multiple mains, the compiler wouldn't know to start. And if you have multiple files with the name main, the compiler will indeed complain to you about it. This int right here means that our main function is going to return an integer value when it completes. An integer just is a whole number. If we go down one more line, we're going to see printf, hello world. Printf means print this to the screen, this string right here. And a string is any sequence of characters that's enclosed inside of double quotes. And they absolutely have to be double quotes. Those of you that have been coming from a Python environment, you can either use double or single quotes, but C requires that strings be double quotes all the time. And we're also going to see this special slash. This slash is either going to add or remove meaning to the character that comes after it. This /n here means a new line. We also have something like /t would put it in a tab, and if we just do // that's just going to be one slash in that direction. So we're going to have a slightly funnier hello world being printed out because I put all that in. Then here at the end, on the very last line of our program, we're going to see return 0. Return means end the execution of the function and give back this value. When a main function is returning a value, 0 has traditionally meant success. And if your program returned any other value besides 0, it meant that it failed, but it failed for some program-specific reason, and you'd have to go look up the documentation as to what the number that you got back would mean. Also, we can finally see that these curly brackets define what main is. So everything inside the beginning of this curly bracket to the end of this closing curly bracket belongs to main, and that code is the code that's going to be executed. So now if we want to run our code inside of C-line, it's really easy. Just press the play button. You can see on that very first screen that it was building and making the project. And then down here you can see our output, hello world. And we can see that our process finished with the exit code 0, means it successfully finished. If we go in and we get rid of the tab and the slashes to make it look nice, and then press play again, you can see it has to recompile the program. Hello world prints out. And if we change the value here to say maybe 12, we run it, we can see that we finished with exit code 12. But again, you're going to want all of your programs to have an exit code of 0, which means they finish successfully. Also, one thing that's important is that all of our lines that are statements, which printf and return are, they need to end in semicolons. This is part of the C syntax. If you forget to include a semicolon, which is something that I actually did on my very first program, forgot it at the end of every single possible line, our code isn't going to work, our code won't be able to compile because it doesn't follow the C syntax. It's not grammatically correct C code anymore. And you can see that the compiler complained to us that on line 11, it's going to expect a semicolon before the return. So when you get an error, it's generally either on that line or on one of the lines that comes before it. And what's really cool about using the IDE is that the IDE is really nice about highlighting where an error is probably occurring. And you can see because I removed that semicolon, the error is happening right here. We put it back, it goes away, and our code is now able to run again. If we want to run this code outside of C-line, say we were working on it on Mimir, what you can do is put your code into any text editor, save our file, and make sure the end of that file is named .c. The .c means that this is a C file, but you can see that the C file, all it really has is just text. It's just that this text should hopefully be code that can be translated by a C compiler over into machine code and be runnable. Now I'm going to go down here into the terminal, and I'm going to make sure that I'm in that hello world directory. Because right now you can see hello world.c is in hello world directory, the hello world directory, but I'm not. So ls, and then we're going to cd into hello world. Right click the screen, we're there. You can see hello world.c. Now to compile on the command line, you need to run the compiler gcc, and at bare minimum, you need to give the name of the program that you'd like to be compiled, which in our case is hello world.c. Press enter, it's going to compile it, and you're going to see that we now have this new executable guy over here, a.out, and if we want to run it, we do /a.out, and hello world appears on the screen. Though all you need at bare minimum is the name of the file, there are a couple of other options that I suggest you specify when compiling. The first is -wall, and -wall means turn on all the warnings. So the GCC compiler will complain to you if you're doing anything remotely wrong. The other option is werror, which means treat your warnings as errors. When the compiler goes to compile your code, there's either errors, it can't finish the translation of your code into machine code and it gives up, or warnings, it was able to translate your code into machine code, but there may be things wrong with it and it may not work. So if you have warnings, you really do want to make sure that you get them out of your code to help guarantee that it's going to work correctly. The other is -g, and this will allow us to debug the code in the future in case we made mistakes. It allows us to run a debugger on it to be able to inspect our code to help us figure out what's going wrong. And then if we do -o, it's going to allow us to name our program something else besides a.out. So maybe I want to just name this hello.out. .out is the suffix for executables on a Linux environment. And then we still need to give the name of the program that we want to compile, which in this case is hello world.c. Hit enter, and you can see we now have a hello.out, which if we run it, does the exact same thing as a.out, because they're compiled from the exact same C file. So that was compiling on both the terminal here and running your code in CLine. Hopefully you can see that CLine is a little bit easier and that it's going to point out if you have errors. For example, if I made an error back here in Mimir, like I forgot that semicolon, this is just a text editor with some nice highlighting, and it's not going to tell us that anything's wrong. But if I go to try to compile now, the compilation is going to fail, and we're going to get that exact same error that we got in CLine, but we're not going to have that nice highlighting saying that things are going to go wrong. So put our semicolon back into our code, and it's back again and working if we go and recompile it. Now it's able to compile and everything is successful. So that's it for our very first program on our very first video. In the next videos, we're going to do things a little bit more complicated, like get input and start talking about variables and figure out how to print those variables out to the screen. And I will see you guys all next time.